the first element of the power system is nothing but the generating station or the generation. Then the output of the generation is transmitted to the consumer through the various steps. The next step of that is nothing but the transmission line. So the output of the generation is given to the power transformer, which is also called as a generation transformer, situated near the generating station, which steps up the 11 kV generated voltage into 132 kV. That 132 kV is transmitted to the transmission line. Then at the transmission substation, again depending upon the requirement, the voltage level is changed. Then next stage we are having the distribution, where as per the requirement the voltage is stepped down. Then various types of consumers are there. The 11 kV supply is directly provided to the commercial and the industrial consumers, whereas again stepping down the voltage to 440 volt in case of three phase or 230 volt in case of single phase, it is provided to the residential customer or the consumers. So this is the single line diagram of the power system, which you already studied in power system 1. Whereas in case of the power system 2, we have studied that the various faults takes place on the power system, that are nothing but the symmetrical fault as well as unsymmetrical fault. In case of symmetrical fault, all the three phase of the generator or the power system at any stage, that is either at the transmission stage or the distribution stage, will get in contact with each other. But that is the rarest case of the occurrence of fault. But the other types of faults are nothing but the single phase to ground or the line to ground. Two phases will come in contact with each other, that is nothing but the line to line fault, or two phases will comes in contact with each other as well as they make the contact with the ground, that is line to ground fault, that is LG fault. But if such fault occurs, we perform the practicals in the labs, but as the generator as well as the fault locations are only having the distance of 3 to 4 feet, that's how we can easily understand which type of fault is occurring there, as we are making them by ourselves. But if we consider the total power system, then from the generating station, the load centers or the consumers situated far away from the generating stations. That's why we have to erect a huge network for supplying or providing the power to the consumers. And in between that, any fault will take place at any place at any time. So we first of all has to know that which type of fault is taking place as well as where. So for that purpose, we have to apply some gears, some devices that are called as the switch gears. That switch gears help us to know the occurrence of fault as well as in cases the location of fault also. So this is regarding the brief idea. The next is the switch gears. The switch gears are nothing but the devices or the apparatus or the component which we are using for recognizing the occurrence of fault as well as the location of fault. Along with that, for preventing the larger damage to the system, we are using to isolate the faulty section. For that purpose, we are going to use the different type of protection devices as well as the monitoring devices there. All these devices or all these equipments or apparatus are called as the switch gears. So different types of switch gears are we are using here. So we are going to see the classification of that. So classification of the switch gears, they are all the devices or all the switch gears are classified in different groups depending upon the voltage levels. So briefly, we are considering the two voltage levels. First is the low voltage level. So this is the low voltage switch gears, and second is the high voltage, that is the high voltage switch gears. So in case of low voltage switch gear, majorly we are using five types of switch gears. First is the switches. These are nothing but the air brake switches. Air brake means we are using the air as the arc quenching medium here or disconnecting the switch. Second is the Isolators. Isolators are nothing but the manually operated switches but having the large dimensions. Then next is nothing but the fuses. You already comes across the fuses in the previous semester as well as the previous syllabus. Next is the relays. Relays are nothing but the sensing devices. Okay, and last is the circuit breakers. Circuit breakers are also used to make and break the circuit, but circuit breakers can operate manually as well as the automatically also. So six type of major devices we are using in case of high voltages. The first is nothing but the oil switches. These are the switches but whose contacts are immersed in oils for providing the better isolation within the minimum time. Next is again the isolators, which are already discussed in case of the LV switch gears. Then next is the circuit breakers that are also comes in the category of low voltage switch gears. Next is the HRC fuse with medium voltage. The HRC, long form of HRC, is nothing but the high rupturing capacity fuses. These fuses are nothing but the single use fuses but having the high rupturing capacity as well as the high current carrying capacity. Next is the lightning arresters. As the meaning of arrest means to take control. So the lightning is a major problem in case of the rainy season, and to protect the power system from these lightnings which are having the very high voltage as well as the high frequency discharge on the power system, we are using such devices which are called as the lightning arresters. And the last major component which is used in case of high voltage switchgear is nothing but the current transformer and the potential transformer. Current transformer is known as CT in short form, as well as the short form of the potential transformer is nothing but the PT. The CT and PT are also called as the instrument transformer because they are always connected along with the measuring instrument for monitoring purpose. So this is the brief classification of the switchgear.